My name is Gamanji, and I'm a cloud platform engineer for Condé Nast. Around 1.5 years ago, I joined Condé Nast to contribute to a project that aims to create a centralized, globally distributed platform that has Kubernetes at its centerpiece. Today, however, I'm going to talk about Kubernetes Scalability, more specifically Federation and Cluster API, and how we integrate and prototype these tools within our platform. I would like to start today by giving you an overview of what Condé Nast does and delivers as a product, as well as our infrastructure and our ecosystem. I'll follow that by giving an introduction of Federation v2 and how we prototype this tool to have a centralized mechanism to deploy application to multiple clusters. And finally, I will talk about Cluster API and how we're prototyping this tool to have a more efficient and effective way to create clusters in different infrastructure providers. So, without any further ado, I would like to introduce Condé Nast to you. Condé Nast has set the benchmark for print and digital publishing for more than 110 years. We operate brands that are fashion and luxury oriented, and you might be familiar with some of the brands like Vogue, GQ, Wired, Vanity Fair, ADM, and more. These are just a few of the brands we have in our portfolio. Currently, we have 38 brands, and we distribute them in 26 languages. So quite an inclusive range we have out there. With headquarters in London and New York, we operate in 12 countries and have 86 websites overall. They generate more than 330 million unique users every single month. And so far, we distribute 37,000 articles to our users every single minute. So it's quite a considerable customer base we have out there. Now, I've mentioned that we operate in 12 markets. However, if you look at the areas, you can see that they're quite geographically dispersed. Historically, all of these regions had quite an individualized tech stack with very little shared components in between them. This includes the systems to deliver the live traffic, as well as the systems to write and deliver the content. Another inconsistency, which was actually quite big for us, was the visual and design, as it made it difficult for us to provide a unified experience for all our customers. As such, we kicked off a centralized digital transformation project that aims to create a centralized platform, and we globally distributed it across 5 different regions, making a total of 9 clusters. We have 3 clusters in Europe, 1 in Tokyo and 1 in Mexico. We have 2 dedicated clusters for China alone. And we have 2 more clusters in Dublin to host our internal tools. However, if you look at the map, we can see that we don't have a replica of our tech stack in Russia. This is because the current strategy is to deliver the content from our European servers while having a CDN which is Russian-oriented. This will ensure our service availability in Russia while investing minimal engineering effort. Our platform is live since October last year when we first launched GQ France. Since then, we migrated 2/3 of our intended estate, and so far we serve more than 250 million page views from our backend systems. So again, quite a considerable amount of requests have accumulated over time. Now, this is pretty much a very quick overview of our platform. And I mentioned that we have 9 different clusters. The way we distribute our applications, or actually deploy our applications to these clusters, is to have pipelines with very similar stages to run in every single region. Now, it's not necessarily inefficient. However, if you'd like to have a change for your pipeline, you have to do it in every single region as well, which is quite tedious to maintain. And we started to think, is there a way to have a more centralized mechanism to deploy our applications? And we stumbled across Federation v2. Now, what Federation is, it's a mechanism to manage application and services in multiple clusters. One point I would like to take across, Federation is not about cluster management. Federation is about application management. And I'm going to repeat this over and over again today, I think. When we're talking about Federation, we talk about SIG multi-cluster, which is in v2 and requires a Kubernetes 1.13 to run. v2 means that there was a v1 at some point. What they actually tried to do in v1 was to wire the code for Federation within the Kubernetes code base. This was very inefficient because most of the time they had to keep up with all the releases and the changes in the code base. So they changed the approach completely in v2. They're using the building block principle, which makes the best use of custom resource definition. And another project I'm going to talk about today from the SIG multi-cluster is cluster registry. Now, cluster registry is very tightly coupled with Federation, and it is a tool that has all the information and associated metadata to connect to the clusters. I'm going to talk about this later on as well. So let's look at how federation works. Supposedly you have already a multitude of clusters, different regions, potentially different infrastructures provider. The way federation works is going to have a host cluster, and every other cluster is going to be perceived as a member cluster. On the host cluster, we require the cluster registry installed as well as the federated APIs. The cluster registry, as mentioned, is going to have all the information required to connect to the member clusters. And the federated API actually needs to run on the control plane to make sure we have all the controllers to reconcile the federated resources. In a nutshell, the host cluster is going to be the control plane and is going to push configuration to the member clusters. I would like to focus slightly a bit more on the manifest of federation. Now, there are two more bits of information we require: the cluster placement and the configuration overrides. With the cluster placement, we say where we want our application to run, and the configuration overrides, we can tailor every single application to the cluster. Let's look a bit more in details for them. Cluster placement offers two variables for us to configure: cluster and cluster selector. With the cluster, we have a declarative list of all the cluster resources we want to run our application on. So in this particular case, we say we want to run it in cluster 1 and cluster 2. We have an option for cluster selector as well, which makes the best use of the labeling system in Kubernetes, which is actually quite powerful. The cluster selector will say we want to run this application on a cluster resource that matches this label. So in this particular case, we have a label region EU Central 1, which means we want to run our application in Europe only. It is worth to mention that cluster and cluster selector can be specified, both of them at the same time. However, cluster is going to have precedence of a cluster selector. Just a fine detail to keep in mind. In terms of the configuration overrides, we'll be able to patch, add, or remove any configurations we want for an application. In this particular case, we say where we want the change to happen and to which resource. So we say in cluster 1, do override the amount of replicas to 5. This is going to make a bit more sense when you look at the entire manifest for a federated deployment. So this is how a federated deployment looks like. In the spec section, it's similar to deployment, so I completely omitted that. No changes there. However, we're going to have the 2 points of information we've talked about: the placement and the overrides. So what we say here is we want an Nginx deployment, and we want this deployment to run in cluster 2 and cluster 1, and we want an override on the amount of replicas to 7, and this is going to be in cluster 2. The end result is going to be we're going to have an Nginx deployment in cluster 1 with 3 replicas, in cluster 2 with 7 replicas. And I think we're actually going to see this in demo. Hopefully my session is still up and running. Can everyone see? Hopefully. So what I actually have here, I already have 2 federated clusters, cluster 1 and cluster 2. And they are in a ready state, which means I can propagate configuration to them. So in today's demo, what I'm actually going to show you is how can I federate a namespace and how can I deploy a federated deployment with different configuration. First of all, let me see where I am. Right. So I would like to look at the demo federated namespace manifest file. So what we actually have here, we have a very basic definition for a namespace. So we create a test namespace and we place it into clusters. Now, if I do a kubectl in my cluster 1, I'll be able to see a test namespace, which is pretty much the basic one, and I would like to federate it. If I issue the same command in cluster 2, I will have no test namespace. To do that, I'm going to deploy my federated namespace resource. So I'm going to do a kubectl apply-f federated namespace. Now, once it has been created, in cluster 2, I should be able to see a new namespace which has been federated. Now, the commands I'm issuing is from cluster 1. Cluster 1 is my control plane. Now, let's look at something a bit more complex. Let's look at a federated deployment. So A manifest file for that is going to look something like this. It can seem quite verbose, but what we actually do here is we deploy an Nginx deployment, and we want 3 replicas for it. What I would like to draw your attention towards is the placement. So we say, again, in cluster 1 and 2. And in the overrides, we actually have a few more details we want to tailor. So we say in cluster 2, have 5 replicas instead of 3. Do run a different Nginx image, so it's going to be 117 instead of the latest Nginx image. And we add an annotation as well. So let's actually deploy that. kubectl apply my federated deployment. So what I'm going to do, I'm going to get all my deploys in the test namespace. In cluster 2, I have 5 replicas. In cluster 1, I have 3 replicas. Great. Now, let's look at the image tag as well. So if I get a YAML output of this, and I grab the image, in cluster 1, I see I have just the latest Nginx image. And if I issue the same command in cluster 2, I'll be able to see that I run a 117 instead. So this is how we tailor it. But we added actually an annotation. So let's look at the annotation as well. So in cluster 1, I'm going to look at all the annotations, and I'm going to grab 3 lines after. What I have is just an automatic, a default annotation added to the deployment, which is the revision. And if I issue the same command in cluster 2, I'll be able to see that I have a new annotation, which is full bar, which we actually added ourselves. So this is like a very quick demonstration of how federation works, but more importantly, how can you tailor your application to the cluster if need be. Before I move forward, I would like to leave you with a few takeaways about federation. Now, federation is about resource management. It is not about cluster management. It is quite an important thing to keep in mind. With federation, actually, we have a new feature, which is the namespace scoped control plane. In the actual demo, I used an entire cluster to represent a host cluster. This feature actually enables us to use just the namespace and federate one namespace across different clusters. It's a great feature to use in production if you'd like to test federation. Conditional scalability, it's quite tricky, but it's worth to mention here that the source of truth for a deployment is going to be within the federated deployment, not within the cluster. So when we create a new deployment with amount of replicas, and we have an HPA object, that value of the, for example, if you scale up your application through the HPA object, that value is not going to be retained. However, federation allows you to do that through a retention flag. So it is possible, but you have to be mindful of that. And another important thing about federation is the higher level behavior. Now, this is something which is quite a powerful feature that comes across the multitude of clusters. It comes with a very sophisticated scheduling mechanism, which can comply with requests such as, I want to run 1,000 replicas of my application at all time. Now, if a cluster goes down, the scheduling will be able to identify that we don't have enough replicas, and it will schedule them on the available clusters. This is a great mechanism for failover, as well if you'd like to migrate applications between the clusters. And another high-level behavior, which is quite important for federation, is the ingress and DNS. When you'll try to access your application, it will actually return you all the endpoints available from all the clusters. Now, we have been talking about application management on multiple clusters. At Condé Nast, we started to think, how can we create clusters more efficiently? Because we have quite a few of them, and we actually going to extend our platform even more. And we need a more efficient way to create our clusters, but more importantly, to be cloud agnostic. And I'm going to explain why. Now, Kubernetes underpins the entire infrastructure at Condé Nast. That means that it's going to be the core component of our platform. We are a CoreOS house, meaning that we're using Tectonic installer for our cluster deployment, and we're using etcd for the storage of our cluster data. Using Tectonic allows us to plug into different cloud providers while consuming the compute and networking resources. As such, we deploy 100% open source Kubernetes in a multi-master, multi-node fashion. Now, I would like to focus on China and Russia. Now, from these two countries alone, we have 60 million unique users every single month. and they represent 20% of our entire digital readership. However, deploying infrastructure to countries like Russia and China can be quite challenging from an infrastructure standpoint. When we kicked off the project for a global transformation, we did not have a clear vision of one cloud provider that's going to be used for all platforms in all regions. As such, this enforces our decision to go with a self-hosted Kubernetes solution. This means that we're going to manage our own clusters, and we're not going to outsource this to a third party. And another thing I would like to draw your attention towards are the Kubernetes bootstrap tools. We have plenty of them available at the moment. We have kubeadm, kubespray, kops, Tectonic, which we actually use in-house. However, if you look at every single tool, they will support a specific cloud provider. They will not support all of them. So if you're locking down to a tool, then you lock down to a specific amount of infrastructure providers that you can deploy your infrastructure into. As well, in our case, Tectonic, for example, is no longer under active development and is to actually be merged with OpenShift Container Platform. We need to think about how we're going to deliver our cluster in the future in a different way. Hence, we stumbled across Cluster API, which is a tool that provides a unified set of APIs to manage the creation, deletion, management, and maintenance of the cluster. Now, when we talk about Cluster API, we talk about SIG Cluster Lifecycle, which had its first initial release in April this year. So it's been around for half a year, not too long. It's currently in V1 Alpha 2, and very soon to be in V1 Alpha 3, with a bunch of new features, actually. Now, when we talk about Cluster API, we talk about this common interface to integrate with different infrastructure providers by having minimal changes to your manifests. So currently there's a bunch of cloud providers in collaboration with Cluster API, such as Google Cloud, AWS, Baidu Cloud, which is a Chinese provider. So if you'd like to deploy our infrastructure to China, we do that with minimal changes to our manifest. We have Bare Metal, DigitalOcean, and many more. The list goes on. Now, let's look at how exactly Cluster API works. Supposedly, we would like to create a number of clusters in different regions, different infrastructure providers. The way this is going to happen will require a management cluster. For testing purposes, you can use Kind, which is an easy and straightforward way to create a Kubernetes in a Docker kind of cluster. But it's great to actually start testing with Cluster API. If you'd like to use Cluster API in production, then it's recommended to use a production-ready cluster as well to have a more failover and more complex failover strategy. Now, there is a dependency we require on the management cluster. Those are the controller managers. Let's look a bit more into them. There are minimum 3 controller managers you require for your Cluster API process to be working. First of all, you require the Cluster API CRDs. These are going to be the cluster, machine set, and machine deployment. There are 4 of them, but they'll actually ensure this higher level kind of layer of configuration for your clusters. Secondly, we require a bootstrap provider. Currently, we have kubeadm and Talus being supported. Now, this particular provider is going to ensure that an instance in AWS or GCP or any other cloud provider is going to be added to the Kubernetes cluster as a node. So kind of quite a powerful integration over there. And lastly, we'll actually require the infrastructure provider. This is going to be responsible to interact with the API and provision actual infrastructure, such as instances, VPCs, subnets, whatever is out there. Once we have our dependency in the management cluster, we'll be able to provision our target clusters. So from one cluster, we'll be able to create as many as we'd like. And I think, another thing I'd like to focus, and this is going to be quite important during the demo, which is going to be just in a couple of minutes. We have 4 CRDs. I mentioned them: cluster, machine set, and machine deployment. With cluster, we're going to have this high-level configuration available for provisioning our cluster. So we're going to have, for example, the subnets for our pods or services. Machine configuration is going to be very similar to an instance configuration. So we'll be able to specify the version of Kubernetes we want to run, the type instance for a different infrastructure provider, region, IAM roles, and so forth. We're going to look a bit more in details. Machine set is going to be very similar to replica set, meaning that we're going to ensure that an amount of machine resources are going to be up and running at all time. And machine deployment is very similar to deployment. Now it's going to ensure that we have a very powerful rolling strategy for our machine resources. Now let's look a bit more in details of how Cluster API works. And I think I have enough time as well. So, what I actually have here, I would like to draw your attention to the first 3 pods. These are my controller managers. The names are actually shortened, so maybe not that straightforward. The first one is the Bootstrap provider, which I'm using kubeadm. The second one is the AWS provider, and the third one is the Cluster API CRDs controller. I have all of them up and running. Now, what I'm actually going to do, just need my clicker. I've already provisioned my cluster, and let's look at how the cluster configuration is going to look like. So if you look at our cluster configuration for AWS, it's very straightforward. I'm going to have a cluster resource, and I say I want this particular subnet for our pods. As well, here we have our infrastructure provider, which is an AWS, and here we specify the region as well as any SSH keys we want to attach to our instance. It is worth to mention that this particular resource, cluster resource, is going to create a Bootstrap a bastion, which will ensure that once we create our cluster, we'll be able to have traffic from external world. Now, let's actually look at how we would create our control plane in AWS. This is going to be a bit more verbose, but this is going to be how we actually configure our instance. So what I actually have here, I have a machine instance, and I just say I want to run Kubernetes 1.15.3. And these are 2 references. So here we're going to have the Bootstrap provider configuration and the infrastructure configuration. These are just references because they're going to be defined later on. So if I look at my Bootstrap configuration, it's very verbose, but I'm going to draw your attention to this particular thing. What we have here is kubeadm config, and we actually invoke an init configuration. When we want to add multiple other nodes, we're going to invoke a join operation from kubeadm. And in the infrastructure provider, we say that we want our instance to be a T3 large. We want to have an IAM role attached to that particular instance, and we want to attach a specific SSH key pair. Now, let's apply this particular resource. So I'm going to do a kubectl, apply our control plane. Now, if I do a kubectl get clusters, I have the one provisioned, which I already mentioned that I've provisioned with the previous manifest. If I do a kubectl get machine resources, which we just deployed, we actually see that it's pending. So ideally, at some point, if my AWS session console is still up and running, we'd be able to see a new instance appearing over here at some point. It's still pending. Well, unfortunately, I don't have time, but I'm more than happy to go in more details with a full demo for Cluster API. As well, you can visit the link provided here, which is a recorded demo of how to provision 2 clusters, one in Docker and one in AWS, in less than 10 minutes. I'm going to move forward. Unfortunately, the time is quite short today. I'm going to leave you with a few takeaways about Cluster API. Now, Cluster API has been around for half a year, but it's been so successful and effective because it uses the building block principle. It makes use the best use of custom resource definition, and it doesn't actually create a new way to provision clusters. Another feature about Cluster API which makes it so important for us is the fact that it's cloud agnostic. Now, this will allow to have this common interface to plug into different infrastructure providers while having very minimal changes to your manifest. What you'll have to change usually is just your infrastructure reference. So from AWS, you're going to put it in Docker or GCP. And the last thing about Cluster API is still experimental. If you have a use case for it, please use it and please feedback to the community. Now is the time to actually tailor Cluster API to your use cases. And the same goes with federation. Please do feedback to the community. I have written, actually, this is going to be a very quick overview. I have written 2 articles about federation and Cluster API, which will help you to get started. please go there. There's actual practical bit that will help you to get started with it. And finally, if you'd like to work with us, please visit the link provided here. As well, I'm going to be available on social media for any questions you have in regards to today's talk. Thank you.